1997. Microphones scattered across the Pacific Ocean, thousands of miles apart, pick up the exact same sound at the exact same moment. It's loud enough to register on equipment built to detect nuclear tests, louder than a blue whale. And not one scientist listening that day could tell you what made it. Scientists nicknamed it the Bloop, and for over a decade, it sat in a government database as one of the loudest unexplained noises ever recorded in the ocean. By the end of this video, you'll understand exactly what picked it up, why it took 15 years to get an answer, what that answer turned out to be, and why, even now, a few pieces of this story still don't fully add up. This isn't a monster story. It's better than that. It's a story about how something as simple as sound can reveal the true scale of our planet. To understand why the Bloop mattered, you need to understand how the US Navy was listening to the ocean in the first place. During the Cold War, the US built a network of underwater microphones, hydrophones, stretched across the seafloor. Officially, it was called SOSUS, the Sound Surveillance System. Its job was simple: listen for Soviet submarines. Sound behaves differently underwater than it does in air. It travels farther, much farther. A loud enough sound in the deep ocean can cross entire ocean basins before it fades out. That's exactly why this network worked. A submarine engine 1,000 miles away could still leave a signature. When the Cold War ended, a portion of that listening network was handed over to NOAA, the National Oceanic and Atmospheric Administration, for civilian ocean research. Scientists suddenly had access to some of the most sensitive underwater microphones on Earth. And in August of 1997, those microphones picked up something they weren't listening for. The sound arrived in a rising bloop-like pattern, hence the name. It lasted about a minute. Low frequency, powerful enough to be picked up by sensors separated by roughly 5,000 kilometers. Let that sit for a second. 5,000 kilometers. That's the distance from New York to the coast of Portugal. For a sound to register clearly across a gap that size, whatever produced it had to be extraordinarily loud. Loud enough that researchers immediately started comparing it to the loudest known sound-producing animal on the planet, the blue whale. Here's the problem. The Bloop was louder, not by a small margin either. Estimates at the time put it several times more powerful than a blue whale call. And blue whales are already the loudest animals that have ever lived. Louder than any dinosaur is believed to have been. Louder than a jet engine at close range. So the obvious question followed almost immediately. If this wasn't a whale, what was it? This is the part of the story that made headlines. And to be fair to the scientists involved, they never claimed it was a monster. But they also couldn't rule out an animal, and that gap was more than enough for the idea to take off. The reasoning wasn't baseless. The Bloop's acoustic signature had some characteristics that resembled biological sounds, an organic-seeming rise and fall, rather than the flatter tone typical of most geological or man-made events researchers had cataloged. If it was an animal, its size would have to be almost unimaginable. Larger than a blue whale, potentially far larger than anything known to exist in the ocean today, alive or extinct. That single unresolved possibility was enough. Within a few years, the Bloop had worked its way into popular culture, cited in Cthulhu mythos, discussions, cryptid forums, deep-sea horror fiction. A government hydrophone recording of unknown origin, sitting quietly in a NOAA database, had become a modern sea monster myth. But here's what almost never got mentioned in those retellings. NOAA scientists were also comparing the Bloop to something far less exciting than a monster. Ice. Antarctica is not silent. It's one of the loudest places on Earth. Acoustically speaking, you just can't hear most of it in air. Ice shelves are enormous slabs of frozen fresh water, some the size of small countries, sitting where glaciers meet the ocean. As they shift, crack, and eventually break apart into icebergs, they generate massive stress fractures deep within the ice. Those fractures release energy, and in the ocean, that energy becomes sound. A lot of it. This is called a cryoseism, or an icequake, and it's a well-documented phenomenon. Researchers had recorded icequakes before the bloop was ever detected, and some of those recordings had a strikingly similar, rising, groaning signature. Here's what makes this genuinely interesting. Not just, oh, it was ice, mystery over. For an icequake to produce a sound loud enough to register 5,000 kilometers away, in the middle of the Pacific, the event generating, it would have to be enormous. A fracture running through an ice shelf covering a huge area, releasing an amount of stress most people never think about when they picture a glacier. In other words, if this theory was right, the bloop wasn't evidence of an unknown creature. It was evidence of just how violently our planet's ice can break. Here's the part of the story that rarely gets told. For over a decade, this question just sat there. The bloop wasn't a top research priority. It was one recording among thousands in a database built for tracking submarines, not solving ocean mysteries. NOAA researchers had a working hypothesis icequake, but confirming it meant deploying additional hydrophones specifically in the Southern Ocean, near Antarctica, and gathering years of comparative data. That takes funding. It takes time. And frankly, for a while, it took a backseat to research that had clearer, more immediate value. Meanwhile, online, the mystery only grew. Every year, the case stayed technically unsolved. The monster theory picked up more traction. That's worth sitting with for a moment. The absence of an answer isn't the same as evidence for the wildest explanation, but it sure gets treated that way. By the early 2010s, NOAA had finally deployed a denser hydrophone network near the Antarctic Peninsula. And with years of new icequake recordings to compare against, the picture started to come together. In 2012, NOAA's Pacific Marine Environmental Laboratory published its conclusion. The bloop's acoustic profile was consistent with icequakes, large-scale ice fracturing events, most likely from the region near Antarctica. Not a creature, not an unknown organism. Ice, breaking under its own immense weight, loud enough to be heard across an ocean. And once you know what you're listening for, it's not the only one. NOAA's hydrophone archive has other named mystery sounds: Julia, slowdown, train, upsweep, most of which have since been tied to similar geological or ice-related origins. But, and this is worth being honest about, consistent with, isn't the same as proven beyond any doubt. A handful of researchers have pointed out that the exact triangulated origin point of the original 1997 recording was never pinned down with full certainty, and some finer details of the acoustic signature still generate quiet debate in specialist circles. The broad explanation is well supported. The precise mechanism, in this one specific case, is treated by some scientists as strong probability rather than airtight. That's not a loose thread left for drama. That's just what real, honest science looks like. Confident conclusions, with margins that stay open until more data closes them. Here's the moment where this story actually becomes more interesting than the monster version ever was. Think about what actually happened here. A crack, deep inside an ice shelf on the opposite side of the planet from where most of these hydrophones sat, produced a sound wave that traveled through open ocean for thousands of kilometers and arrived clear enough to be picked up, measured, and analyzed by human instruments. That's not a myth. That's physics. That's the ocean acting as one continuous planet-scale medium for sound, carrying the sound of a breaking glacier to the far side of a hemisphere. The real discovery here was never a creature. It was a demonstration of how connected and how loud our planet actually is, in ways that are invisible to us because we simply can't hear them the way the ocean can. There's something almost humbling about the ending to this story. We wanted a monster. What we got instead was proof that our planet is constantly, violently alive in ways most of us never witness. Ice shelves are still cracking right now, today, somewhere off Antarctica, and every one of those fractures sends sound rippling through an ocean that carries it farther than almost anything we experience on land. As those ice shelves face increasing pressure from a warming climate, these events aren't slowing down. If anything, understanding sounds like the bloop has become part of how researchers track the health and stability of Antarctic ice from thousands of miles away. using the ocean itself as a listening device for a continent we can't watch, constantly with our own eyes. The bloop was never a monster in the deep. It was the sound of the coldest place on Earth, cracking under its own weight and reminding us, from 5,000 kilometers away, that the planet is always speaking. We just have to be listening. If a single crack in the ice can travel that far, it makes you wonder what else the ocean has recorded that we still haven't figured out. And that's actually exactly where we're headed next.